And I'm going to start by going over to, what do I do now? I'm going to start by, okay, here we go. Going over to our home page. And shooby dooby doo. What do we got going? Again, as you come to find out, I keep posting these right after class, the recordings of the classes. Side cameras. Most of you already have this in a math class as well. There's PDFs the department has created. My question is, do you want a practice like test or something, or do you think you're all good because you've done it in math classes? Okay, I'll take that as all good. We can move on from there. Stop sharing. Um, Today we're going to be using chapter 18 in the Gaddis book. So there's a bunch of code listings from that. If you want them, you can always download them and have them as source code for you to use. All right, so let's get ready. And chapter 18 in the Gaddis book is something called linked lists. Let me change my view to speaker and get me on here. Me. It is something called a linked list. Okay. This is an abstract data type, something new that we're going to cover. And as we go from after today through the rest of the class, we're going to learn a concept and we're going to say, oh, how would this work with arrays? Versus how will this work with something called a linked list? Okay, so today we're going to take some of that idea from list that we talked about last week. We took the list and we looked at them in terms of arrays. Now we're going to take a list and look at it in terms of a linked list, and then we're going to compare these two ideas as we go through the rest of the semester. So everything we learn about after today, we're going to say, oh, how would this go with an array? How will this go with a linked list? Okay, so an array was static. We're switching to this linked list. It's dynamic. It changes. Okay, it dynamically allocated data structure. Oh, structure, ding, 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 ding. That's the word I know from before. A struct. That was 161, something that was important. Will link together in memory to form a chain. Once I know where one is, I'm going to go find the other one. And the way I do that is I'm going to create this new data type, and it's going to be a structure. And the structure is going to hold a value, just like an array did. But in an array, the next value was stored in the memory address right beside it. Here, the next piece of data is going to be stored by storing the address in this linked list structure. We're going to create nodes. The node's going to have a piece of data and a pointer. The pointer is going to get the value to where the next node is. Or the pointer might point to a way to end all this nonsense, and that would be to a null. We had null pointer, we had all caps null, we had zero. Bunch of things represent this null. Depending on the IDE, some will work and some won't. Yeah, like I said, null pointer or straight up all caps null. We'll cross that bridge in a little bit. All right. So in order to create this node, and right now our node only has one piece of data in and one pointer. Down the road, we're going to have more stuff in these nodes. We may have two, three, nine pieces of data. We may have a pointer going one direction, a pointer going another direction, two unique pointers in the node. For now, though, we're just going to have piece of data and a pointer. So I'm going to come in and I'm going to create a struct. And this was its own data type. Okay. Struct, I'm going to say, all right, I'm going to put a value in there, and I want to use the data type list node, right? This is the data type right here. And I want to create a pointer called next. What did we have before? We had things like int pointer, where we pointed to an integer value, right? That was my data type. Now my data type is actually the one that I'm creating. It's going to point to something that looks like itself. And again, this was some of that stuff back in chapter 9. Everybody said they're pretty good. Now, this is a lot like a vector, something that you covered in 161. Some advantages. It's faster, easier to insert. We don't have any shifting going on. It's also going to be easier to delete. Some people will say, I still like vectors better than arrays. Well, we have something a little bit better than a vector. And that's this new data type we create right here. Okay, so when it comes to linked lists, we need to be able to get started. All right? And what we're going to do is create a pointer. It's going to have different names as we go throughout the course, but the pointer in this case is going to be called head. This pointer will point to a node. Then the node could point to another node. It could point to null. It could. So we start with something called head. All right. Keep that in mind. We talked about this last week. Once I get a new data type, how can I work with it? How do I add to it? Do I need to append? Depends. But what functions am I going to create for this data type when I create my class? I probably am going to need an insert. That's for sure. I'm going to need a delete. I need to put one in. I need to be able to take one out. I need to traverse. These are like the big three right here. Input, delete, and traverse. That's for manipulating the data. Do I need an append, like add to the end? Don't know, question mark. Is it empty? Is it full? Well, is full is kind of silly because it's dynamic. It's never full. So is full is going to be yeah, we don't really need is full. But we want to get in the habit of every time, what functions do I write about my data type? My data type being this linked list. All right. Now I see people looking at the screen and looking down, which helps me to know that you're still writing. But I think for the most part, you caught up. I hate when you have to do a lot of writing versus listening. So I want to make sure you're all good. As I've always told classes, if I go too fast, you have to tell me to slow down or I won't know to slow down unless I can read body language and so forth. Okay. This is great. This is great. If I look in the Gaddis book for just one section, 18.2 comes in and all right, so I'm getting ready to set up my header file. Inside of my header file, I create a struct. This is going to be a node, a list node. Okay. I create one that's called head. So this is a pointer. It's a list node. It's my data type list node. It doesn't hold a value. The only thing we're worried about here is where's the first node located? Now, how would I know if this is empty? How do you know if my linked list is empty? Well, when I create head, one of the first things I should do is have it point to nothing. So here in my constructor, I say head gets the value of null pointer. And again, depending on the compiler, instead of null pointer, it could be null, it could be zero. A couple of different options that could go in there. Okay? So the first thing I'm going to do when I get ready and create a node is I get head and set it equal to pointer. So my linked list is pretty good right now. I have something that's called a destructor. Going to get rid of it. Clear all my memory up. And I have methods. Here's one called append. Here's one called insert, delete, and display. I don't need is full because it's never full. And my is empty would be the same as saying, does head equal null pointer? Check this line of code out. What if I wrote in here if head? What's that mean?
If head has a valid input or not?
Okay, what does this parenthesis always evaluate out to be? True or false, right? When would it be false? If head equals null pointer. Null pointer, null, zero, false. So if head, that means head's true, that means there is something. So if I was checking to see if it's empty, I would say if not head. Nice little shortcut. This if there is something that's true, if it's not, the not of it makes it false. If it's false, it would skip out. So we can use that kind of handily, taking it from this idea of null pointer, null, zero, false, all those things are good. All right. So what we're going to do is we are going to take a look at how to append. We're going to start writing pseudocode, get an algorithm for append. And let's see what we would do. I'm looking at create a node. Okay, when I create a node, shooby dooby doo, I'm going to create a node, give it a value. So this is for when I created a node, this became null. All right. So I have a node. Now I may possibly have a linked list created already. So I need to start thinking, what are my options? Well, my options might be head points to a node that points to a node that points to a node or to null. Another option would be head points to null. In this case, my list is empty. So if I want to append, I want to add it to the end. I want to add it to the end. All right, so we're going to get our hands a little bit dirty here. Let's see what's going on. If yeah, let's see. If it's empty and I'm appending, so first thing is, how do I check to see if it's empty? I'm going to do this. If head equals null, or whatever version of it there is. So if head points to null, and again, we said, why not use not head? So if it's empty, if so, then what's going to happen? Head gets the value of this new node. What are we going to call this? Up here, this is called new node. Head gets the value of new node. Again, what was head? Head is a pointer to a node. And I'm done. Else, what am I going to have to do here? So I took care of
Look,
this case. Yeah, go ahead.
we'll look down the stack and then check
Yeah.
if that's full or empty.
So I'm going to have to traverse through here until I find the end. Hmm. Hmm. So I need to traverse through here. All right. So I'm going to do this. I know there's something in the list. So I'm going to say, I'm going to let temp pointer get the value of head to get this party started. All right. So I'll have temp pointer now points to this node. All right. So now I need to go through. So this is where you are starting to finally come into the realization of I need to write a bunch of this stuff down before I go anywhere. Uh, we have two items. What if head only pointed to one item? Is that going to make a difference? But head temp pointer gets the value of head. Now I need to go through and get to the end. Sounds like a loop to me. So I'm going to do this. Um, this guy right here, temp pointer. So the first thing I need to talk about is when I'm creating all of these, I need to have some sort of arrows and things kind of going on. All right, what's he talking about? Let's back up and go to my original node. Where is it? My original node. Okay. So up here in my original node, I have two things, a value and I have a pointer. The pointer's name is called next. Okay. The pointer's name is called next. So when I come in here, I have two things that might happen. My new node, all right? I could say something like this. New node, now use this arrow, value equals 6. So in order to store a value in new node, I'm going to say new node's value is 6. Okay? And also along with that, new node's next equals null. So when I created a new node, that's how I set it up. And I'm going to use these things, this arrow, which it's a dash greater than sign. Okay, it becomes an operator for us. These are the two fields, you could say, inside of our struct. So we're going to give them values. So when I get in here, oh, I got a bunch of good stuff going on. I'm going to say, all right, we took care of this guy. He's done. And, I had no, I didn't take care of that. I took care of this guy. But we come in, and how are we going to know when I'm at the end? Huh?
And the next pointer equals null.
Yes. So let's take a look at something. Let's do head. And there are going to be times where I say, did you draw the picture? Draw the picture. I come in here and I have 6 and I have 12 and I have 13 and I have null. Okay. So I just came in. The first thing I did was I said, okay, we have a list. So my temp pointer gets the value of head. So now I have temp pointer, lowercase t. Temp pointer now holds this address of this node. Now I want to know what is temp pointer's value. If I said system.print.outline, or well, wrong language. If I said see out temp pointer's value, what would get displayed?
6.
6. Good. If I said temp pointer's next, what would get displayed?
12.
Not 12, because remember what next is. Next holds an address. So that's this. Temp pointer's next is going to hold the address of this guy. This next node. Temp pointer's next holds the address of the next node. Ah, okay. So I'm going to come in here and I'm going to have a while loop because so right now we got it and it's pointing to here. And I'm going to ask the question if, watch this, because I may have to build around it. If temp pointers next equals null, what's that mean? If temp pointers next equals null, that means there's nothing else in the list. If this points to, so say I'm going through and go, and I get out here, temp pointers pointing to here, temp pointers pointing to 13. If temp pointers next equals null, then what would I like to do? I'd like this to point to my new node. I'd like this to now point to my new node. If temp pointers next equals null, I'm going to say, wait a minute, I'm going to change this guy to new node. That occurs, I'm going to say temp pointers next equals new node. So that's how I'm going to assign it. That's how I'm going to assign it. You're now into heavy. You're starting to get into heavy comp sci. If temp pointers next, if temp, so right now we're saying temp pointer points to this node. If temp pointers next equals null, I want temp pointers next to now point to new node, which then points to null. So it's a way for me to append. Okay, so that's going to go, that is going to go over inside of here. If ding, 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 all that's in there. Now, how do I go through the list? Is my next question. That's going to be and when we're good. So let's keep thinking about this. Um, while there's another item, I mean, we need to just keep going through here. So while let's see, I'm going to put something like temp pointers, temp pointers next. If it points to something, this is going to be true. If it points to something, this is going to be true, which means we come in and say, if da 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 da, good. Now, if this is false, then what do? I checked here. Its next didn't equal null. So I'm going to have to say else temp pointer gets the value of temp pointers next. This will now say temp pointer, which pointed to here, now gets this pointer, and temp pointer would now point to there. It helps me traverse through. Now I know why I tell you don't start typing right away. Talk about grunt work. This will get easier. The traversal will get easier. The Boolean statement will get easier. Working with the arrow with the next, the arrow with the value will get easier. Why? Because we're going to do it every single week. We're going to be working with linked lists. All righty, let's see what we got. We got to look at something that's a little bit cleaner than all of our scribble. But I want you to know how important the scribble is. Another pseudocode. Store data, right? In new node. We did that. Create a node and store it. If there are no nodes in the list, then make head point to my new node. Make it the first one. Otherwise, traverse through the list to find the last one, add the node to the end. Well, that's a lot more generic than what we did. Okay? A lot more generic. So let's see what we got. We have a why is it going that way? Let's go this. We have a function in our class. It's called append node. It's going to bring a value in. It's going to add that value to the end of our list. Please stop me if you're confused at all at any point. Thank goodness for documentation. You'll find that this becomes big. Okay. Here's a list node, points to a new node, right? Our data type is list node. We have a pointer and a pointer. Two node pointers we need. The first one is going to point to my new node. This second one is what I was just calling temp pointer. It's called node pointer. Makes sense. It's pointing to a node. This one is for my new node that I'm creating with that value coming in. This one is to help me traverse through. First thing I do is what are you doing here, buddy? I'm hitting my dock cam. No wonder. All right. First thing I do is I create a new node. I store the num and I store null pointer in here. Okay. That's this new node bad boy up there. He's used to create this. Next, I come in and if there's nothing in the list, if this is a true statement, the not of false. If head points to 0, it's false. The not of that is true. That means there's nothing in the list. Head gets the value of new node, and that's the address of new node. So when I say new node, that's its actual address. Otherwise, we come in and remember we use temp pointer. Temp pointer now points to where head was pointing. Again, this is an address. Looking back, it's an address. It holds the address of a node. This holds the address of a node. This just happens to be the new one we're working with. All right. So I come in and this guy is going to traverse me through the list. While there's a next one, I'm going to, so our loop is a little off. While there's a next one, I move it over. Node pointer gets node pointers next. This is going to keep going until that points to null. Line 31, when this gets to the last one, that'll be null. Okay, that's going to kick me out of that loop because we've now found the end. And what we're going to do is take the end where node pointer's pointing right now, and then point it to new node. Ooh. Can I get a ooh? No. No who's? Not Horton. Is there a Horton in here to give me a who? Ooh. Are you ready to break out on your own, or do you want to keep trying it yourself? See, here we have an example. This is in the book. The book, the book walks through nice and slow what everything's doing to add it to the end of the list. Keeps adding and it keeps adding. What is all the work for this function? All right, so I was going to do insert or let you do insert, but I think we should probably do insert together. Y'all okay with doing insert together? We did append, which added to the end, but now we're going to do insert. And the way we're going to do insert is to keep in mind that this is a sorted list. Okay, so I want to insert something. Let me readjust here. And that, so we just looked at the function called append. We're now going to take a look at the function called insert. All right, oh boy, insert. So let's see what I have. I need to start drawing, not drawing. I'm going to say head points to null. I'm going to say head points to 6, 10, 20, and null. I don't know. Am I have to take care of this guy if there's only a single item? I'm just drawing that. I don't know right now what's going on. Do. So let's see. I'm just going to start scribbling. If it's empty, if empty, just add it. If empty, head gets the value of new node. Heck, took care of that bad boy. Now I'm going to be inserting into a sorted list. Give me some possible numbers to insert. Test data, right? Test data. What do we got going? Possible numbers to insert. What do we got?
4.
Excellent. Give me another number that we'd want to insert.
15,
15. Give me one more number that we'd have to insert.
30,
30. Things to think about as I go through this. Things to think about as I go through this. All right. If empty head equals new node, and if not, then I'm going to get ready and I'm going to take off. So I have a new node, and new node is a pointer to a node. That's going to be null. This is going to be the value I insert. This is going to be a value I insert. So I'm going to come in and I'm going to traverse through, and oh boy, I could do this. Whew, I'm at least putting something down. Else, I'm going to call it temp pointer again. Nice. So right now, temp pointer points to the first node. Tell me what you're thinking.
Well, the temp pointer equals next. Then I'm guessing also have a check to see if the data we're in trying to input is less than the next one's
Okay.
data.
So I'm gonna do this right now. Temp pointer points to that node. All right. So your first thing is we want to insert a 4. All right. I'm just gonna start scribbling stuff as you tell me, and then we probably will have to refine it. So to go ahead, say it again. I think it was Nicodemus. Was that you?
Yeah,
Yeah. Okay. Go ahead.
I was like trying to think of trying or figure out how a way to use the last piece from append the while temp pointer equals next. But
Okay.
as also I was trying to figure out how to include that with also checking to see that the data we're inputting is less than the next position's input.
Yeah. Yeah. So I'm going to take care of this first case. And as I think you said this, if new nodes data, the new nodes data, which in this case right now is a 4, if new nodes data is
Less than the next node's data.
less than, if new node is less than what?
A temp pointer.
Yeah. I don't want to get over here too far. It's, data. Then what do you want to do?
Um, I guess you would want to insert the new node before it.
Okay. So go ahead, give me some ideas. I want to put my new node before temp pointer. Well, this is a special case, right? Because it's going in the beginning. It's going in the beginning. So for this special case, I'm going to have to do something like head gets the value of. So I want head to point to.
You want it to point to the new node, then have
Excellent.
the new node point to number 6 in the.
Yep. And then new node would get the value of. So this pointer, oh, not new node's pointer. What were we calling it? Pointer? Or new node's next, excuse me. New node's next. This guy would point where? What has the address of where I want to point?
Oh, the temp pointer.
End pointer. The order of this is going to be important because I may move tempo. Oh boy, I draw good. Head now points to new node. New node we want to point to the same place because head doesn't point to here anymore because I just moved it. Head. So this first line says this guy now goes over and points to him. So this was a special case because I have head involved here. It's going to be different than when I get ready to do 15 out here. All right, so I took care of case 1, beginning. Put it in the beginning, the middle, or the end. It's good we did this as a group, huh? Okay. So I'm still in my else statement. So right now, temp pointer doesn't. This guy came through. It wasn't true, so I didn't insert it. So what do I want to do now? So right now, temp pointer points here. I know the value's bigger, like 15.
Wouldn't you have the pointer next go to the next position.
Okay. So you're saying this temp pointer you want to move to the next position?
Yeah.
Well, if I have to insert it between 6 and 10, I just lost my 6.
Yeah, so then you need to keep you need to be able to see both of them at the same time.
So you'd like another pointer? Okay. Okay. So I checked, blah, blah, blah. This wasn't true. So now I want to get in and loop. Agree? I want to get in and loop. But my question is, as I get in and begin to loop, I'm going to get something similar to this, but not exactly this. Temp pointer points right here, right now. Let's break it down into just that. We're going to microscope it. So right now, temp pointer is important to me. It points to 6, and 6 points to 10. New node points to my new node, and let's just say this is 8. So I want to put it in the middle. Okay? We just microscoped it. How's this middle going to work? Well, right now, I just found out this is bigger than this. I know that. I'd like to know, is this less than this? Let's do a little trivia here. Temp pointer value. What is it? 6, right? 6. So right now, temp pointer's value is 6. Watch this. What is temp pointer next value? Temp pointer is an address. I now go to the address, which is over here, and I get what?
You
I
would
get
get
10.
10.
data.
Yeah, I get the 10. Well, that's kind of crazy. Nicodemus suggested another pointer, which is definitely possible. You could have a back and a front type pointer, but we can actually get to these values. Okay, so right now I came in and I know my 8 is bigger, so I'm going to say something like this. If, oh boy, here we go, temp pointer, the next node, its value, if that is less than, wait a minute, if that is greater than new node's value, that is greater than new node's value, I want to insert it. How's that for a statement? If temp pointer's next value is greater than new node's value, then I want to insert it. Oh boy. Then I want to insert it. Okay. Let's see. If I was drawing lines, if I took this line and pointed here, what would happen? If I took temp pointers next and pointed it to new node, what would happen?
You would be looking at new node, but you wouldn't be able to see 10 anymore. So you need to point
Right.
the address back to 10.
Good. So what would I need to do first? I'm going to need to take new node's pointer and point it to here first. New node's pointer has to go here first. Didn't lose anything yet. And now this guy's pointer has to go to new node second. Oh boy. Let's see what I got. I drew the picture, and now I can say new nodes next. That's this pointer. It's going to get the value of that's this red line. It's going to get the value of that arrow right there because that's an address, right? Well, it's going to be temp pointers next. This line 1, new nodes next, that's this address right here, is now going to get the address that was stored there. So we'll point to that node. Second line I need, temp pointers next. Equals the address of new node. Yeah, once again, temp pointer is an address. Temp pointers next is also an address. Okay, this is a pointer to nodes. This is also a pointer to nodes. Those two are both addresses. So this is an address, this is an address, this is an address, and this is also an address. New node is an address. New nodes next is an address. Oh boy. So that's a bunch of good, this is loaded right here. This is my meat and potatoes for putting in the middle. Still going to need to traverse through the list in case this isn't true. This is false, I'm going to do something else. But I needed to learn how to do the basic idea of inserting. Boy, somehow I'd have to get this back over into this code. That took care of the 4. We have a block that's going to help us with the 15. We're probably going to use a lot of the concepts here like we did append. That might be how we use our loop to get all the way through. Insert. What? Bum, 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 bum. I got $20 in my pocket. That's not right. Notes from a different class. Same kind of idea. Insert. Is it empty? If it is, we do this. If not, we got creating test data. And then we go through. We have a whole bunch of stuff to take a look at. I didn't even realize I had this page. It just fell out of my notes. Inserting a node. If you're checking out the text, create a node, store the data. Good. If there's no nodes, do that. This is really bad. Oh, this was kind of important. Whose value is greater than or equal to the node, or we're at the end. Yeah, we had to take a look as we went through, and the entire insert written out looks like this. Oh boy. Oh boy. Guess what? It's done and it's written for us. That's kind of nice. If previous node equals null, that looks like they're using previous node, and there's a lot of different ways to do this. Okay, there's a lot of ways to do this. Oh man, that is long. And again, we're calling a function append node. Sometimes it'll just be, that's append from earlier. Here's insert node, 10 and 5. We're going to look at the program in a minute. Before we look at the program, let's just do a little chit chat about delete, and then we'll get to the program. All right, so I have, oh boy, What if I wanted to, if it's empty, I'm done. If I have a list, linked list, and I want to delete the three, okay, that I get to the five and I'm done. Da, da, da. I want to delete the five. What about something in the middle that doesn't exist? What about something in the middle? What about something at the end? So a bunch of thought has to come into play before I do anything about the code I need to write to take care of what situations. I got $20 in my pocket. I think what we're going to do is not that, not that. That went with that. I like that. I don't think I need that one anymore. I don't need that one anymore. I got this and this. So I want to use a fresh piece of paper. And, we just saw a moment ago all that stuff. I can use that stuff. Where are we at here? Dum. Here I am. Here I am. So if I'm looking at this, I think one of the hardest ones is going to be like to delete 10. Okay. If it's something that's in here, all I need to do is figure out a way to jump out, some sort of flag that'll help me get out of my loop. Yeah, we're not going to find it. We don't need to keep traversing because this is higher than the number between it. So let's just go into a breakdown, and I'm going to take the list and I'm going to say head. Head points to 5. And again, we're just doing part of the code, not taking care of all of these right now. 5 goes to 10. 10 goes to 15. All right, so we have something to work with here, and I think we're ready to roll. All right, so I would like to delete. I would like to delete 10. All right, I'm going to come in and I don't know how much is here or there, but right now, temp pointer is pointing to the address of that node. It's coming right to here. Oh, I want to delete 10. So what do we got? Somebody tell me what we got.
This is just a guess, but if 10 pointer equals or 10 pointer next equals our test data, and then if that's true, then we would start looking at trying to figure out how to get our pointer after that's address. No, you would get the address from the one we're trying to delete.
Right. So if 10 pointers next, somebody help me out. You missed a little part there. If 10 pointers next, which is an address, I don't want the address. I want the value at that address. Now this guy says 10. 10 pointers next, value. Okay? If that equals, we'll just say delete 10, we'll call it num. If that equals num, I'm ready to delete. And again, we're only looking at deleting in the middle. We're not looking at all those cases. I want you to think about it, see if you can get it. You want to write it while you're writing it. We got the big reveal coming up. Ready? Temp pointers next. That's that arrow right there. Gets the value of temp pointers next. Next. This line would now go and get the address of that. It would steal this value. So it's done all in one. Now, this is where you would remember I used a term earlier, destroy a node. You would destroy this guy. You know, you'd hang on to it somehow, free up the memory and get rid of it. So this was just the case of deleting in the middle. Earlier, 35 minutes ago, you were going, what the heck is going on with all? If I would have given you this line, you would have had no idea what it was. Now, at least some of you have an idea. I don't know. Hopefully, all of you have the idea. But temp pointer is an address. I want the address that's right here. Okay? I want that to become this address. So I give temp pointers next, temp pointers next, next. Nice. Oh boy, let's put all this together. So what you now have is in your I gave you code listings for chapter 18. Okay? Go get that and load it up. Go get that and load it up. We want the what do we want? We want the .h file for numbers dot number what is it called? Number, let me find it. Make sure we have the right name. Number list.h. I want you to load that up. Okay. If there's a number list.h, there better be a file where all those are written out. So number list.cpp is going to contain all of the functions that we want. Inside of number list.cpp, yeah, you know me. I said a CPP. Sorry. In number list.h, we say, hey, you better have an append, an insert node, a delete node, and a display list inside of there. Oh. Display list on the end of it says const. That means I don't want you screwing up my list when you're displaying it, right? Yeah. We want to lock that bad boy down. But inside of all three of these, you should be able to start to see the code. So you now own numberlist.h and numberlist.cpp. You don't have to write it. Hopefully you understand it by what we did today, but you don't have to write it. These are now, if you ever need to do something and store values into, you need to store 4,000 values, you can use the header file and the spec file. Boom. They're yours to use now. Hopefully you understand what each of these are doing. And it'll get easier and easier and easier as we go. So if you now ran, what's the latest one? I'm guessing 18.4. If you ran code listing 18.4, yeah, we're using number list, yada, yada, yada. We have a class called number list. We are creating an object called list. from the class number list. Doesn't know where it is? Yeah, it's called numberlist.h. I'm using some of the functions. I'm appending. Letting us put values 2.5, 7.9, 12.6. So hopefully after you wrote that, the very next thing you write is display so that you can run the program up to this point. Then you get ready and you try to delete 7.9. Okay. Then you go on and on. Here's another display. Now you delete a number. Then you display it again. Delete another one and display it. I think 18.3 had insert where we were inserting numbers into the list. But this is us demoing to make sure our delete node works. What do you think about that? You now own it. What? That's right, you own it. If you look at 18.3, a linked list template. Wonder what that means, a linked list template. What's going on in this template? Well, you see up in line 7, this is called a template class. And by adding a couple of lines, I can set this to be doubles, ints, whatever I want to store as a value. Char. So this becomes, and you'll see templates as we go through, and it's this, we set it up, class T, template, capital T, and it becomes pretty nice to use. We don't do a lot of work with it. I mean, almost everything else is the same. We don't do a lot of work with it. We'll do some template work later that makes a little more sense. But here I can work with whatever data type I want. So you created your first ever abstract data type. Actually, you did enums, enumerated a long time ago. It wasn't very important, but that was the same kind of deal, creating your own. We just create our own with methods and functions and all kinds of good stuff. All right. Are there any questions? Are there any questions? Quick look here. There are some variations to this. One is, oh, check this out. My node has 2 pointers. Right? This is an awful looking one. But we're going to do work with doubly linked list, which means I have a pointer. The way this is drawn, I don't like it all. I have a pointer that goes before, which in this case is null, and a pointer that goes to the next node. And I have a pointer here that goes to the previous node, and a pointer here that goes to the next node. I have a pointer here that goes to the previous node, and a pointer here that goes, well, we're done, so it goes to null. The variation, we will use this. We will draw the nodes totally different than this. Okay. Here's another variation. I get to my last one, and it points to the same place head does. It's called a circularly linked list. It goes around and around and up and down and a 1, 2, 3 kick. 1, 2, 3 kick. Questions? 1161. Page 1161. Number 2. Okay, here's if this is where we're not meeting 2 days, but things that you could try working with what do we call it? Linked list.h? Did we call it? What was it back in the chapter? It
Isn't
was
it number list?
number list. Yeah, number list. It's called number list. You could take the .h and the .cpp file, and you could, if you wanted to, like play with it. Add some other functions other than the basic insert, delete, append. Um, Add a print member function, right? Something to display all the values in the linked list. I don't know that we necessarily had one or not. An empty list, put some numbers in. There was display back there. Here, can you reverse the list? What would you do to reverse the list? Reverse the list. If I had a list of 4, 6, 12, how would I reverse it? How about I create a new list, add 4, insert in the front 6, insert in the front 12. So I would get this node and head would point to that. Head would point to 4, then I would insert 6 before the 4, so head, and then insert the 12 before, and so I could reverse a list, create a function like the ones we saw already to reverse a list. Extra for experts, do try this on your own if you would like. Otherwise, we're just about out of time, and I'm just about out of voice. I know that upsets some people, but any questions on this number list, this linked list class that you now have advantage to work with?